This is lesson 93, VHDL example 63. And in this example, we'll take a look at the VHDL while statement. And we'll look at it through the eyes of the GCD algorithm. Here's Euclid's algorithm for finding the greatest common divisor of two numbers. Suppose you have the number x and y starting with 15 and 10. Here's the algorithm. While x is not equal to y, x is not equal to y. If x is less than y, x is not less than y, so we go to the else. X is x minus y. 15 minus 10 is 5. And this is a while loop, so we go back and check it again. X is still not equal to y. If x is less than y, it is less than y this time, so y is equal to y minus x. Y minus x, 10 minus 5 is 5. Go back to the beginning of the while loop again. In this case, x is equal to y, so x not equal to y fails, and so we go down and we set the GCD, the greatest common divisor, to x. So the greatest common divisor of 15 and 10 is 5. So this is a typical algorithm that includes a while loop, an if-else statement, and sequential statements such as x equals x minus y. It turns out those are the only three statements you need to write any computer program. It turns out that any computer program can be written using a while statement, such as while x is not equal to y, then you do these instructions and keep repeating as long as that is true, and an if-then-else statement, as shown here, and sequential statements such as y equals y minus x. So while statements are very important for describing algorithms. I would like to be able to implement algorithms in an FPGA. When we do this, they'll execute much faster than the same program executed in assembly language. For example, this algorithm in this little C program, if you wrote it in assembly language, or if you compiled it, it would compile to assembly language and then to machine code. It would then be stored in memory, typically flash memory, in a microcontroller, say. And when you executed it, in each case you would have to fetch the instruction, decode the instruction, and execute it. So this all takes clock cycles in time. And so if you were to implement this algorithm directly in hardware, then it would execute much faster. In addition, you could often execute some of these instructions in parallel. So the question is, does VHDL have a while statement? Well, in fact it does. So let's try to write this GCD algorithm using such a VHDL while statement. The inputs are x and y. Let's just make them 4 bits for this test. And the output is GCD, also 4 bits. And then let's just write Euclid's algorithm directly. Here it was over here. So let's write a process x and y. We need to make variables. We'll call them x variable, y variable, 3 down to 0. We'll set these x and y variables to x and y, and then we'll just write this algorithm directly. While x variable is not equal to y variable loop, this is the way VHDL while statement works. While this is true loop, and then you go down here to end loop. That's how you tell where the end of the while statement is. If x variable is less than y variable, that's the statement, y variable gets assigned y variable minus x variable, else x variable gets x variable minus y variable. So that's just this Euclid's algorithm, and then we set GCD equal to the x variable. So that's it. So the question is, does this work? Well, let's try simulating it. Well, the simulation works. Look at, we picked y of 8, and then we let x go 2, 4, 6, 8, 10, 12, and here's the GCD. 2 is the greatest common divisor of 2 and 8. 4 is the greatest common divisor of 4 and 8. 2 is the GCD of 6 and 8. 8 for 8 and 8. 8 and 10 is 2. Here we finally get an interesting one. 8 and 12 has the greatest common divisor of 4. So in fact, the simulation works. So let's try to synthesize it for our FPGA. Whoops, it doesn't work. We get this error. What does the error say? Loop has iterated 64 times. So we have errors. It doesn't synthesize. Why doesn't a while loop synthesize in VHDL? Well, look what happens here. This says while x variable is not equal to y variable, but what are the values of x variable and y variable? Well, it depends on the inputs x and y. Well, we don't know what the inputs x and y are when we compile this, so there's no way to build hardware that will work. You remember when we had a for loop, that did synthesize. We had a for loop. We knew how many times we were going to go around the loop. And you remember what happened in for loops? Every time through the loop you generated new copies of the hardware. So the hardware kept getting copied all the way along as many times as you went through the loop. But for a while loop, we don't know how many times we go around the loop because it depends on the input. Therefore, a VHDL while loop will not synthesize. You might wonder, why have a VHDL while loop? Well, it's useful sometimes for writing, say, test benches where you don't need to synthesize it. You can use a while loop in that case because it does simulate, as we've seen. So the question is, if a while loop doesn't synthesize, how can we write a VHDL program that will implement this GCD algorithm? Well, we'll take a look at how to do that in the next lesson.